Dear students, I am Priyanka Dikshit, working as Assistant Professor at School of Pharmacy, Babu Narsidas University, Lucknow. Today's topic of discussion is gastrointestinal agents. Hyperchlorhydria or hyperacidity. Whenever excess secretion of acid takes place in the stomach, this causes the imbalance in acid-enzyme ratio, thereby finally leading to hyperacidity and ulcers. And acids are basically used in the treatment of hyperchlorhydria. Hypochlorhydria. Whenever inadequate secretion of acid takes place in the stomach, this causes achlorhydria or hypochlorhydria. Acidifying agents or acidifiers are primarily used in the treatment of hypochlorhydria. Acidifying agents or acidifiers. These are the drugs or agents which are used to increase metabolic acidosis and gastric hydrochloric acid secretion. They are also known as acidifying reagents or acidifiers. Example is dilute hydrochloric acid. Antacids. Antacids are the drugs or substances which are alkaline in nature and are used for neutralizing excess acid in the stomach in the patient suffering from hyperacidity. Example is sodium bicarbonate, aluminum hydroxide gel, magnesium carbonate, milk of magnesia, tribasic calcium phosphate, and magnesium hydroxide. Acidifying reagents or acidifiers. They include gastric acidifiers, urinary acidifiers, systemic acidifiers, as well as acids. Antacids. Antacids may include systemic or absorbable antacids, example sodium bicarbonate. Non-systemic or non-absorbable antacids are further categorized into aluminum-containing antacids, calcium-containing antacids. Examples of aluminum-containing antacids are aluminum hydroxide and aluminum phosphate. Calcium-containing antacids includes calcium carbonate and tribasic calcium phosphate. Magnesium-containing antacids includes magnesium carbonate and magnesium hydroxide. Combination antacid preparations includes aluminum hydroxide gel and magnesium hydroxide mixture. Acidifying reagents or acidifiers. These are the drugs or agents which are able to increase the acidity of the gastrointestinal tract. Some of these drugs are used to increase metabolic acidosis, whereas some others are used to increase the gastric hydrochloric acid formation or secretion. They are also known as acidifying reagents or acidifiers. They include gastric acidifiers, which are the drugs which are used to temporarily restore the acidity of the stomach in patients suffering from achlorhydria or hypochlorhydria. Urinary acidifiers are the drugs which are used to render the acidic urine to enable treatment of some types of urinary tract disorders. Systemic acidifiers. These are the drugs which are able to neutralize the alkaline body fluids, particularly blood, in patients who are suffering from systemic alkalosis. Acids. Acids are primarily used as pharmaceutical aids in the preparation laboratory quality control. Dilute hydrochloric acid. Formula is HCl. Molecular weight is 36.46. Ingredients are hydrochloric acid and water. Hydrochloric acid is commonly known as spirit of salt because it was first of all prepared by distilling sea salt with sulfuric acid. It is an aqueous solution of hydrogen chloride in water and is having not less than 35% weight by weight and not more than 38% of HCl. Preparation of hydrochloric acid. It is basically manufactured by the action of sulfuric acid on sodium Further, calculated quantities of concentrated sulfuric acid and sodium chloride are heated in the cast iron pans of a salt cake furnace. The hydrochloric acid gas is formed, which is passed in a tower which is sprayed with water. The dilute hydrochloric acid is collected at the bottom. It is again circulated to the tower to absorb more hydrogen chloride so that it gets concentrated. The acid so produced is then purified. Sodium hydrogen sulfate formed in the process is mixed with some more quantity of sodium chloride and heated strongly in the muffle furnace to get more hydrogen chloride gas. Sodium chloride reacts with sulfuric acid to form sodium hydrogen sulfate and hydrochloric acid. Sodium hydrogen sulfate further reacts with sodium chloride to form sodium sulfate and hydrochloric acid. During the manufacturing of caustic soda by electrolysis of sodium chloride solution, larger quantities of hydrogen and chlorine gas are obtained as byproducts. These gases are combined further to yield hydrogen chloride. To yield hydrogen chloride, S2 reacts with chlorine gas to form hydrochloric acid. Properties: it occurs as colorless liquid and it is strongly acidic in nature. It is mixable with water alcohol having a specific gravity of 1.18. It is a strong acid and attacks metal, forming their hydrochlorides with the evolution of hydrogen gas. Even in highly diluted form, it is strongly acidic to the litmus. It is mainly used as pharmaceutical aid or as an acidifying agent. It is used as an gastric acidifier when the levels of hydrochloric acid in the gastric juices are low. It is externally used as a solvent catalyst in basic pharmaceutical as well as an acidifier. Antacids. These are the drugs which are usually alkaline in nature and are used to neutralize the excess acid in the stomach in the patient suffering from hyperacidity, which is a condition in which the level of acid in the gastric juices is excessive that causes discomfort. Production of gastric HCl is a continuous process. It means the use of antacids is also a continuous process. Strong alkaline bases will damage the mucosal layer. The action of antacids should be gradual without evoking rebound acidity. Also, antacids should not have any side effects. Antacids should give symptomatic relief from pain by neutralizing excess acid such as hydrochloric acid, so they may find use in the treatment of ulcers by reducing the pain. Ideal requirements of antacids: it should be insoluble in water and has fine particle form. It should not be absorbable and should not cause systemic alkalosis. It should be able to exert its effect gradually and over a long period of time. It should not be a laxative or it should not cause constipation. It should not cause any side effect. It should be stable and readily available. The reaction between the antacid and gastric hydrochloric acid should not produce larger volume of gas. The antacid should buffer in the pH range of 4 to 6. Antacid should probably inhibit pepsin, which is a proteolytic enzyme. Antacid preparations are basically administered as oral suspensions, mixtures, tablets, chewable tablets, capsules, and oral products. Evaluation of antacid activity is done by acid neutralizing test. Aluminum hydroxide gel. It is an aqueous white viscous suspension of hydrated aluminum oxide having varying amounts of basic aluminum carbonate. The preparation may sometimes have methyl oil, peppermint oil, glycerine, sucrose, or saccharin as a flavoring and sweetening agents, and up to 0.5% sodium benzoate as a preservative. Preparation. It is mainly prepared by adding hot solution of potash alum slowly with constant stirring to a hot solution of sodium carbonate. After complete removal of carbon dioxide, the precipitated aluminum hydroxide is filtered out. Then it is washed properly with hot water until it gets free from sulfate impurities, and precipitate is further suspended in distilled water to get the required strength. 3 molecules of sodium carbonate reacts with 2 molecules of potash alum in the presence of water to form 3 molecules of sodium sulfate, potassium sulfate, 2 molecules of aluminum hydroxide with the evolution of carbon dioxide gas. Precaution: alum solution is added to the solution of sodium carbonate and not vice versa. Properties of aluminum hydroxide: it occurs as a white viscous suspension. Aluminum hydroxide gel gives astringent aluminum chloride when it reacts with gastric hydrochloric acid. It results in nausea, vomiting, and constipation. Aluminum hydroxide reacts with gastric HCl to form aluminum chloride and water. Aluminum hydroxide gel is a popular antacid and brings about neutralization of gastric acid by the following mechanism. Aluminum hydroxide gel is non-absorbable and exerts a very little systemic effect. If the gel is formed by precipitation in a carbonate or bicarbonate reaction mixture, there may be some evolution of CO2 when the carbonate or bicarbonate anions react with gastric acid. But this reaction is very slow, so the patient will not feel discomfort. Other drugs should not be taken with antacids simultaneously, as there will be loss of antacid property. And product of neutralization of aluminum hydroxide gel with hydrochloric acid is aluminum chloride, which is water-soluble astringent salt. This may cause constipation, nausea, and vomiting. Uses: it is very effective, slow-acting antacid. Aluminum hydroxide reacts with hydrochloric acid to form aluminum chloride and hydrogen chloride. It doesn't get absorbed in the alimentary canal and doesn't produce carbon dioxide. It is basically used in the treatment of intestinal toxemia and hyperchlorhydria, whereas it does not cause systemic alkalosis. Magnesium hydroxide or milk of magnesia. Formula is MgOH whole twice. Suspension is having not less than 7% and not more than 8.5% weight by weight of magnesium hydroxide in purified water. It may contain suitable preservatives, and it is also known as magnesium hydroxide mixture. Preparation: although this preparation is having magnesium hydroxide, but it is not obtained by suspending magnesium hydroxide, whereas it is obtained by reacting sodium hydroxide with magnesium sulfate. Magnesium oxide reacts with water to form magnesium hydroxide. Another reaction includes treatment of magnesium sulfate with sodium hydroxide to form magnesium hydroxide and sodium sulfate. Light magnesium oxide is mixed with a solution of sodium hydroxide to get a smooth cream. It is now distilled with water and the suspension is poured in thin stream into a solution of magnesium sulfate, stirring continuously. The precipitate is then allowed to settle. Now, clear upper liquid is removed by the decantation process and the residue is transferred on a calico filter. Now the residue is washed with water until it becomes free from sulfate ions. Further, the precipitate is mixed with required water to get the sufficient volume. Properties: it occurs as white uniform suspension. Its varying proportions of water may separate out on standing. Uses: milk of magnesia is a popular antacid and has a laxative action. It is used as alkaline mouthwash. Constipation. Constipation is difficult evacuation or emptying of bowels. It is associated with hardened feces. Symptoms of constipation. Symptoms of constipation are swollen abdomen, abdominal pain, hard stools that are painful to pass, and very few bowel movements. Causes of constipation. Causes of constipation are not having enough water and fiber in your diet, pregnancy, medicines, irritable bowel syndromes, etc. Cathartics. Cathartics are the drugs which are used for the treatment of constipation. They may be defined as the drugs which bring about defecation. They are beneficial for the expulsion of intestinal parasites. Examples of cathartics includes magnesium hydroxide and sodium potassium tartrate. Purgatives. Purgatives are the type of cathartics with stronger action resulting in clearance of more fluid evacuation. Laxatives. Laxatives are the type of cathartics with milder action and they give rise to same effect but vary in nature and mechanism of action. Laxatives, cathartics and purgatives all the three act by retaining the fluid in the bowel. They all three are administered via oral route, that is in the form of suspension or powder, or by rectal route, that is in the form of enema or suppository. Types of cathartics. On the mechanism or on the basis of mechanisms, cathartics can be further categorized into stimulant cathartics, bulk purgatives, lubricants, and saline cathartics. Laxatives, cathartics, and purgatives. Classification includes stimulants. Examples are senna and rhubarb. Bulk purgatives includes methyl cellulose and sodium carboxymethyl cellulose. Lubricants cathartics includes liquid paraffin and glycerine, whereas saline cathartics includes magnesium hydroxide and magnesium sulfate. Stimulants. Stimulants are the type of cathartics that basically act by causing local irritation on the intestinal tract and bringing about stimulation of peristaltic activity. As they act directly on the intestine, they stimulate peristalsis and therefore they are termed as stimulant cathartics. They act primarily by stimulating the sensory and motor activity by acting mainly on the myenteric plexus. As I already told, examples of stimulant cathartics are senna, cascara, and castor oil. Bulk purgatives. Bulk purgatives are the agents which are able to increase the bulk of intestinal contents. They are made from cellulose or other non-digestible polysaccharides. They absorb water in the intestine, swells and increases the water content of the feces. They act by softening the bowel and facilitating the evacuation of bowels. Examples of bulk purgatives includes methyl cellulose, sodium carboxymethyl cellulose, bran, psyllium seeds and isabgol. Lubricant cathartics. Lubricant shows their cathartic action by causing smooth clearance of fecal material. They soften stools by coating the bowel in a waterproof film that makes the stool soft so that it can pass easily. Saline or osmotic cathartics. Saline or osmotic cathartics act by increasing or exerting osmotic effect by absorbing large quantity of water. They act mainly by stimulating peristalsis. They are basically the poorly absorbable cations like calcium, magnesium, and anions like phosphate, sulfate, and tartrate. Magnesium sulfate, also known as Epsom salt, which is an example of cathartic. The formula for magnesium sulfate is MgSO4.7H2O. Preparation of magnesium sulfate. Magnesium sulfate is obtained by the action of dilute sulfuric acid on magnesium carbonate or magnesium oxide or from native carbonate. In the reaction, MgCO3 reacts with sulfuric acid to give rise to magnesium sulfate water, and thereby carbon dioxide is evolved. Further, another reaction that is involving the preparation of magnesium sulfate includes reaction of magnesium oxide with sulfuric acid to form magnesium sulfate as well as water. It can also be manufactured by the action of sulfuric acid on dolomite. Dolomite is having the formula MgCO3.CaCO3. When dolomite is used, magnesium sulfide passes into solution and the sparingly soluble calcium sulfate gets deposited. In the reaction, it involves MgCO3 CaCO3 reacting with sulfuric acid or dolomite reacting with sulfuric acid to form magnesium sulfate as well calcium sulfate, and in the reaction water is formed as well and carbon dioxide gas is evolved. Magnesium sulfate can also be formed by treating hydrated magnesium sulfate with 6 molecules of water to form magnesium sulfate or Epsom salt with the evolution of CO2 gas. Properties. Magnesium sulfate occurs as white crystalline powder. It is colorless, odorless crystals having a cool, saline, and bitter taste. It effloresces in warm, dry air. It is soluble in water and is sparingly soluble in alcohol. When it is gently heated, it loses some of its water of hydration and gets converted into its monohydrate form that occurs as a white powder. Use. It is used as a cathartic, it is used in magnesium deficiency, and it is used as anticonvulsant. Sodium orthophosphate, another example of cathartic. The formula for sodium orthophosphate is NaH2PO4.2H2O. It contains not less than 98% and not more than 100.5% of sodium hydrogen phosphate calculated with reference to dried substance. Preparation. It is prepared by reacting phosphoric acid with sodium carbonate. Phosphoric acid or 6 molecules of phosphoric acid reacts with 5 molecules of sodium carbonate to give rise to 2 molecules of sodium orthophosphate. Also, another reaction that involves the preparation of sodium orthophosphate includes reaction of sodium hydroxide with phosphoric acid to form sodium orthophosphate. Properties. It occurs as colorless, odorless crystalline powder. It is having saline acidic taste. It is freely soluble in water and insoluble in alcohol. It is slightly deliquescent. Uses. It is used as saline cathartic, as a source of phosphorus, and sodium orthophosphate is also used as a buffering agent. Kaolin versus bentonite clay. Kaolin and bentonite also comes under the category of cathartics. Kaolin. Kaolin is a clay which is rich in kaolinite mineral. Kaolin is a clay which is rich in kaolinite mineral, whereas bentonite is a form of mineral which mainly consists of montmorillonite. The general chemical formula of kaolin is Al2Si2O5OH4, whereas the general formula for bentonite varies with the dominant chemical element present in the clay. that is sodium bentonite. Chemical formula includes Al2H2Na2O 13Si4. Chemical structure. Kaolin consists of tetrahedral silica sheets and octahedral sheets of alumina. While one silica sheet links to an octahedral alumina sheet via an oxygen atom. Bentonite contains three alternating layer structure which has a central octahedral alumina sheet and two tetrahedral silica sheets. Kaolin forms as a result of weathering of aluminum silicate minerals such as feldspar. Bentonite forms from volcanic ash in the presence of water. Uses. Kaolin is useful in the paper industry, in the ceramic industry, and to produce toothpaste as an ingredient in the skincare products. Whereas bentonite is useful for drilling mud as a binder, as a purifier, as an adsorbent, etc. Coming on to the next topic, that is antimicrobial agents. Antimicrobial agents are the chemicals or drugs and their preparations which help or which act by reducing or preventing or by killing the microbes or microorganisms. Antimicrobial agents can exist in variety of forms such as antiseptics, disinfectants, germicides, bacteriostatics, and sanitizers. Antiseptics. Antiseptics are the agents that kill or prevent the growth of microorganisms. Antiseptics are applied on the living tissues, that is growing on the man. An ideal antiseptic should destroy bacteria, spores, fungi, viruses, or any other infective agent without causing any harm to the tissues of the host. Disinfectants. Disinfectants are the substances which are used for inanimate objects, that is for non-living objects. They are widely used for home and hospital sanitization. Germicides. Germicides are the substances which act by killing the microorganisms, and they are basically used at higher doses, that is higher doses are needed for the killing action. Germicides can exist in three forms depending upon the type of microorganism, such as bactericide, which is used to kill the bacteria, fungicide when it is used to kill the fungus, and virucide when it is used to kill the viruses. Bacteriostatic. Substances which primarily function by inhibiting or preventing the growth of the bacteria are known as bacteriostatic agents. They do not kill bacteria, that is, they do not give cidal action, but they stop or prevent the growth of bacteria. That is why they are known as bacteriostatic agent. Static means to prevent the growth of the bacteria. Sanitizers. Disinfectants that are used to maintain general public health standards are known as sanitizers. Sanitization is concerned with cleaning and washing away organic matter, that is saliva, mucus, etc. Sanitizers have power to kill microorganisms. Sanitizers do not cause any local cellular damage. Characteristics of an ideal antimicrobial agent. An ideal antimicrobial agent should be chemically stable and cheap. It should have rapid onset of action and sustained activity. It must have good therapeutic index in the concentrations in which it is used. It should not cause any local cellular damage. It should not interfere with the body natural defense mechanisms. It should not show any systemic toxicity. It should have a broad spectrum of activity, means it should be active against a wide array of microorganisms. It should have favorable lipid water distribution coefficient or partition coefficient. It should be able to reduce the incidence of resistance. It should produce minimal toxicity. It should be non-irritating to the tissues. The mechanism of antimicrobial action. The mechanism of antimicrobial action ranges from mild astringent to powerful oxidative agent action. The mechanism of antimicrobial action ranges from mild astringent property to powerful oxidation property. Inorganic compounds generally exhibit antimicrobial action by following three mechanisms: oxidation mechanism, halogenation mechanism, and protein binding or precipitation mechanism. Oxidation mechanism. Antimicrobial agents bring about the oxidation of active functional groups that are present in proteins and enzymes, and the groups or the functional groups that play a vital role for the growth and survival of the microorganism. Examples of compounds that act by this mechanism are peroxides of peroxy acids, oxygen liberating compounds like potassium permanganate. Halogenation mechanism. The compounds that act by halogenation mechanism basically act by the liberation of chlorine, hypochlorite, or iodine. This category of agents act on the peptide linkage of the protein and alters its potential or property by binding with the peptide linkage and causing halogenation of the peptide linkage. The destruction of a specific functional group or amide linkage of the protein causes the death of the microorganism. Protein precipitation. Examples of compounds acting by this mechanism are metal ions, example astringents. Polar groups of proteins bind with metal ions to form complex. This complex formed may be strong chelate leading to the inactivation of protein. Iodine. Iodine contains not less than 95% of iodine. Preparation. Iodine is basically manufactured by seaweeds of Laminaria species or Laminaria algae. Dried seaweeds are burnt to obtain its ash known as kelp. This kelp is further extracted with water and the aqueous extract is concentrated, whereby the sulfate and chloride of sodium and potassium get crystallized, leaving freely soluble potassium and sodium iodide in the mother liquor. Small amounts of thiosulfates and sulfides are decomposed by adding further sulfuric acid. Mother liquor is further treated with iodine chloride, iodine bromide, and magnesium oxide to obtain iodine. This is the reaction that involves the preparation of iodine. Sodium iodide reacts with sulfuric acid in the presence of magnesium oxide to form magnesium sulfate, sodium hydrogen sulfate, iodine, and water. Potassium iodide reacts with iodine chloride to form potassium chloride and iodine, whereas potassium iodide also reacts with iodine bromide to form potassium bromide and iodine. Properties of iodine. Iodine occurs as bluish-black rhombic prism. It is having a metallic luxure. It volatilizes at ordinary temperature. It is insoluble in water but soluble in alcohol. Potassium iodide is able to dissolve large quantities of iodine due to the formation of I3 negative. Uses. Iodine is used as a counter irritant or as an disinfectant. It is used as a local germicide. It is used for proper functioning of thyroid gland. Elemental iodine is used. Various iodine preparations includes aqueous iodine solution, weak iodine solution, strong iodine solution, povidone iodine solution, and tincture of iodine. Aqueous iodine preparation. Synonym is Lugol's preparation, that is, it is also called as Lugol's solution. Aqueous iodine preparation is known as Lugol's solution. It is having 5% weight by volume of iodine and 10% weight by volume of potassium iodide in purified water. Composition. It contains 50 gram of iodine and 100 gram of potassium iodide as well as 1000 ml of purified water. Weak iodine preparation. Weak iodine is also known as tincture of iodine. It is having 2% weight by volume of iodine and 2.5% weight by volume of potassium iodide. Composition. Weak iodine is made up of iodine 20 grams, potassium iodide 25 grams, dissolved in alcohol 50% up to 1000 ml. Povidone iodine. Povidone iodine is an aqueous solution of povidone iodine. It is a complex produced by the interaction between iodine and povidone. It is basically the combination of polyvinyl pyrrolidine. The complex has about 10% of available iodine. It occurs as yellowish brown amorphous powder and has a characteristic color. It is soluble in water and alcohol. The solution is transparent in nature and has reddish brown color and faint smell of iodine. Uses of iodine. It is a powerful bactericidal. It is used as disinfectant for skin wounds and mouth. It is effective in the management of burns and cuts. Important advantage of these preparations over usual iodine preparations are its water solubility, non-irritating property. It is less toxic and non-staining in nature, and it could be easily removed from the skin and cuts by simple washing. Hydrogen peroxide, another antimicrobial agent. The formula for hydrogen peroxide is H2O2. It is an aqueous solution of hydrogen peroxide. It is having not less than 6% weight by weight of hydrogen peroxide, which is corresponding to about 20 times its volume of available oxygen. Preparation. It is obtained by adding a thick paste of barium peroxide in ice cold water to a calculated quantity of ice cold dilute sulfuric acid, whereby the insoluble barium sulfate gets filtered off. In the reaction, barium oxide reacts with sulfuric acid to form barium sulfate and hydrogen peroxide. Hydrogen peroxide may also be manufactured by treating sodium peroxide with dilute sulfuric acid. In the reaction, sodium peroxide or Na2O2 reacts with sulfuric acid to form sodium sulfate and water. It is obtained by the decomposition of barium peroxide with phosphoric acid or whereby per-disulfuric acid is formed, and which on distillation under reduced pressure gives hydrogen peroxide. It is obtained by the decomposition of barium peroxide with phosphoric acid, whereby per-disulfuric acid is formed, which on distillation under reduced pressure gives hydrogen peroxide. It may also be prepared by passing CO2 through a suspension of barium peroxide in water. Reaction involves treatment of BaO2 with CO2 and H2O to form H2O2 and barium carbonate, that is BaCO3. Properties. It is colorless and odorless liquid having a slightly acidic taste. It is a strong oxidizing agent. The solution decomposes when comes in contact with oxidizable matter or when made alkaline. H2O2 decomposes into H2O and O2. The decomposition is promoted by catalysts like copper, iron, and manganese, etc. Assay. In the assay of hydrogen peroxide acts as an oxidizing agent and also acidifying KMnO4 is used, which also acts as an oxidizing agent. These two oxidizing agents reduce one another with the evolution of gaseous oxygen. Hydrogen peroxide reduces KMnO4 solution and causes its decoloration. At the end point, excess drop of KMnO4 gives pink color. So KMnO4 in the assay acts as a self-indicator. Uses. It is used as a strong oxidizing agent and it gives nascent oxygen. It is used in cleaning cuts and wounds as it is an antiseptic and germicide. It is used as a deodorant. It is used in bleaching the hair. It is used as an effective antidote in phosphorus and cyanide poisoning. Chlorinated lime. The formula for chlorinated lime includes CaOCl2.H2O. Chlorinated lime or bleaching powder, it is also known as bleaching powder, is prepared by the action of chloride on slagged lime. Slagged lime is CaOH whole twice reacts with Cl2 to form bleaching powder or chlorinated lime. Properties. Chlorinated lime occurs as yellowish white powder. It has a strong smell of chlorine. It is insoluble in water and alcohol. It is hygroscopic in nature. Chlorinated lime or bleaching powder undergoes auto-oxidation into calcium chlorate and calcium chloride. In the presence of cobalt chloride, calcium chlorinated lime loses its oxygen to form calcium chloride and oxygen. Uses. It is used as a disinfectant. It is used as a bathroom cleanser, laundry detergent, as an algicide, herbicide, and as a bleaching agent, as well as in the preparation of chloroform. Potassium permanganate. The formula for potassium permanganate is KMnO4. Industrial preparation of potassium permanganate. Potassium permanganate is prepared by mixing a solution of potassium hydroxide with powdered magnesium oxide and further the residue is heated in air. Magnesium oxide reacts with potassium hydroxide in the presence of oxygen to form potassium manganate first with the formation of hydrogen peroxide as well. Then potassium manganate reacts with water to form potassium permanganate as well as potassium hydroxide and hydrogen gas. It is also prepared or it may also be prepared by passing chlorine gas through potassium manganate. Potassium manganate reacts with chlorine gas to form potassium permanganate. It may also be formed by treating potassium manganate with hydrochloric acid. Potassium manganate reacts with hydrochloric acid to form potassium permanganate as well as manganese oxide, water and potassium chloride. Potassium permanganate can also be formed by treating potassium manganate with carbon dioxide. Potassium manganate reacts with carbon dioxide to form potassium permanganate, potassium carbonate and magnesium oxide. Properties. It occurs as bluish bronze gray needles. It is odorless. It is having a density of 2.703 gram per centimeter cube. It is having a melting point of 240 degrees Celsius. It is freely soluble in water and alcohol. Its refractive index is 1.59. It is bitter and metallic in taste. Reactions. Potassium acts as a strong oxidizing agent. It oxidizes iodine to iodate and iodine. It oxidizes iodide to iodate and iodine. Camphor reacts with potassium iodide to form manganese oxide, potassium iodate, and KOH. Potassium permanganate reacts with potassium iodide in the presence of sulfuric acid to form magnesium sulfate, iodine, and potassium sulfate. Potassium permanganate oxidizes aldehydes to carboxylic acid. Solid potassium permanganate decomposes when heated. Potassium permanganate decomposes into manganese oxide and potassium magnate with the evolution of oxygen. Uses. Due to its strong oxidizing properties, it is used as an disinfectant and deodorant. It is also used as astringent and as an anti-infective agent as well as a bactericidal agent to kill bacteria. 1 to 5% of hydroalcoholic solution of potassium permanganate is used as wet dressing. Potassium permanganate has been used in attempts to induce abortions at home, but its legal restrictions on the chemical in response to its use as an abortifacient. Potassium permanganate was used as a bleaching agent. Potassium permanganate is used extensively in the water treatment. Boric acid. Chemical formula H3BO3. Molecular weight 61.83 gram per mole. Preparation. Boric acid may be prepared by reacting borax or sodium tetraborate decahydrate with a mineral acid such as hydrochloric acid. Borax or sodium tetraborate decahydrate reacts with hydrochloric acid to form boric acid as well as sodium chloride. Boric acid is also formed as a byproduct of hydrolysis of boron trihalides and diborane. Diborane B2H6 reacts with water or 6 molecules of water to form boric acid with the evolution of hydrogen gas. Boron trihalides reacts with water to form boric acid and hydrogen halide. Physical properties of boric acid. Boric acid occurs as white crystalline solid or granular powder. Its density is 1.435 gram per centimeter cube. Its melting point is 170.9 degrees Celsius. It is odorless in nature. It is sweetest in taste. Solubility. It is sparingly soluble in water and slightly soluble in alcohol. Reactions. Boric acid is soluble in boiling water. When heated above 100 degrees Celsius, boric acid dehydrates forming metaboric acid or HBO2, and when metaboric acid is further heated at 160 degrees Celsius, it is converted into tetraboric acid or pyroboric acid, that is H2B4O7. Further, when pyroboric acid or tetraboric acid is heated above 200 degrees Celsius temperature, it decomposes into boron trioxide, that is B2O3. Boric acid is a weak acid because when boric acid dissolves in glycerine, it gives glyceroboric acid and has ionization constant of about 10,000 times greater than that of boric acid. Boric acid reacts with alcohols to form borate esters, where R is an alkyl or aryl group. Boric acid reacts with alcohol to form borate esters and water as well. Uses of boric acid. Boric acid can be used as an antiseptic for minor burns or cuts. Boric acid can also be used as a weak bacteriostatic, fungistatic, and astringent agent. Boric acid is applied in a very dilute solution as an eye wash. Boric acid is also used as mouthwashes, skin lotion for local anti-infective action. Boric acid is used as an insecticide. Boric acid borate system can be useful as a primary buffer system. Boric acid is used in some nuclear power plants as a neutron poison. The boron in boric acid reduces the probability of thermal fission by absorbing some thermal neutrons. Thank you.